The sensational claim was made by Amir Siraj, a colleague of Harvard professor of physics Avi Loeb, after the pair authored a report entitled Ruling Out the Nitrogen Model for Oumuamua, which was recently accepted for publication in New Astronomy magazine. Oumuamua was spotted by Robert Werrick on October 19, 2017, using a telescope at the Haleakala Observatory in Hawaii. Ever since, the debate over what Oumuamua was has raged within the scientific community, especially given its peculiar, flattened shape, somewhat like a pancake. Professor Loeb courted enormous controversy for his suggestion that it may have been some sort of alien probe powered by a piece of technology he theorized to be a solar sail. Many of his peers are highly skeptical, and 2 studies published in March suggested it could be a large chunk of nitrogen ice from a Pluto-like exoplanet millions of years ago, a so-called nitrogen iceberg. But Mr. Siraj, who as Director of Interstellar Object Studies at Harvard's Galileo project is dedicated to the systematic scientific search for evidence of extraterrestrial technological artifacts, said the latest study, which he co-authored with Professor Loeb, appears to disprove the possibility. He told Express.co.uk, "The nitrogen conclusion has received a lot of attention. However, we show that the nitrogen model requires a mass of heavy elements that exceed the total quantity locked in stars, the absolute theoretical maximum, which means that the model is ruled out." Neither he nor Professor Loeb were drawing any firm conclusions, Mr. Siraj stressed. He explained, "We don't know what Oumuamua was. We just know that it's not nitrogen, since the mass budget would be untenable." Oumuamua's appearance was tantalizingly brief. When was first observed, it was roughly 21 million miles from the Earth and already heading away from the Sun. Between 300 and 3,000 feet long, and 115 and 548 feet thick, and red in color, scientists are positive it originates outside our solar system, but other than that, there is little consensus. As such, Mr. Siraj said it would be foolish to rule anything out, or in. He added, "There's no way to know what Oumuamua was since it is already gone." All plausible possibilities, including the artificial origin one, must be kept in mind during observations of future interstellar objects like Oumuamua. In the meantime, the scientific community remains fixated on an event which is unique in the lifetime of our civilization, Mr. Siraj pointed out, namely the first time an extrasolar object had been tracked, albeit briefly. He continued, "All of the existing theories regarding Oumuamua's provenance invoke never-before-seen astrophysical phenomena, including an ultra-porous aggregate 100 times less dense than air, a planet fragment that was tidally disrupted, exotic icebergs made of almost pure hydrogen or pure nitrogen, or a piece of artificial technological equipment." The up-close study of an object like Oumuamua from outside of the solar system, whether natural or artificial in origin, would reveal unprecedented insights about planet formation and life in the universe, transforming humanity's understanding of our place on the cosmic stage.